Okay, so welcome to another episode of Electronics in St. Andrews. I want to give a shout out to my 2021 electronics students, especially to my very special student, Ashwin Lokesh. Round of applause from his classmates, please. Okay, so as requested by a few of you, you wanted a short video to teach you how to use the Multisim as a revision. So what I've done is that I'm going to set up okay, so this is the end product, right? I want to have a LS390 decade counter connected to a 7-segment display, and then I'm going to have two logic switches, one connected to the clear, this is a pull down resistor, and one connected to the clock A, right? And this is a pull up resistor. So let's run the circuit, and this is what I'm going to teach you how to build, right? So we run it, and every time I click the switch is going to count, right? So open means it's high now, and when I click it shut, there's a falling edge, which this fella will be clocking in, and it counts up 1, okay? So one more time, open, nothing happens because that's a rising edge, and when I click it again, creating a falling edge, it counts up like so, okay? So I'm going to teach you how to build this circuit. So first of all, you need to open up your stop this. We need to open up your Multisim. So when you open up your Multisim, this is what it should look like. Right? Let's open up a blank one. So it should look something like this. Okay, it's nice and blank. Okay, so just a couple of things. One, when you go to, first thing is go to options. Okay, go to global options. Under components, make sure you have chosen the IEC 60617 symbol standard, okay? So this one is what the Americans use, but we are not American, so we use this one, okay? We don't use the NC. So let's click apply. Okay, and we are good to go. Okay, so first of all, let's place the components. What I like to do is I like to get all my components onto my work area first before I start wiring them up. Okay, so let's go to place, component. Now I know I need a VCC. So what I'm going to do is I'm going to come to group. I'm going to go to sources. That's where you find your power. And what I'm going to do is I'm going to click power sources, and I'm going to just use a reference voltage. Okay. So I click that in, and I'm just going to place it somewhere at the top. Next, I'm going to choose a ground. Okay, maybe I use a digital ground. That's fine. Or if you want to, you can also use a reference ground. Whichever suits your fancy, that will be fine. Okay, so I'm going to click it here. Now, I also know I need to create two logic switches. So I come back here. I go to basics. Under the basics, I'm going to go with switch. And under the switch, I'm going to look for a single pole, single throw. There are so many different switches here. Dip switches, single pole, double throw, single pole, single throw. And since I just need a single pole, single throw, I'm going to use this. So this will kind of replicate my push button as well. Okay. So I'm going to rotate this fella. Now listen carefully. To rotate it, I'm going to press Control and R. Okay, so I'm going to press Control R and it rotates. When I click Control R one more time, it's going to rotate, and it keeps on rotating until you are happy with its position. So let's say I'm happy with this position. I'm going to click one here, and I need two switches, so I'm going to click it one more time, and I'm going to rotate it one more time, and I'm going to maybe put the other switch up here. Remember, one will be a pull up, one will be a pull down. Next, what I do need next are resistors. So I'm going to go with a standard 1K. Since it's already 1K chosen, I'm going to use 1K. I'm going to rotate it to this position. You can align it. I need one more 1K, so I'm going to click it one more time, rotate it into this position over here. Okay. Now next, I need a LS390. So if I don't know where it is, for example, I don't know what in the world, where do I even find an LS390? I just come here, click search, under component, you click a 74 LS390. Okay, and then click search. Give it some time, and it gives you these two. Doesn't matter which one you go for, whether you go for the D series or the N series. I'm going to go with the D. Click OK. Comes here, so it's already chosen for you. That's what I want. So right now, it actually shows you that it's under the transistor logic family. Okay, so in future, you know where to go. Your 74 LS series, they're all here. So the 390 is what I want. Click it. Now, remember there are two counters in the LS390. So today we are just going to make use of one. Okay, so I'm just going to click the A. I'm going to click it anywhere somewhere here. And that's all I need, right? Just the one. Now, I also need a counter. Sorry, that was the counter. I also need a 7-segment display module. So just now we went to the component. We typed in a component number. But let's say we don't know what the component number is, but we do know the function, right? So we want to type in a 7-segment. That's its function. Click search. And it comes up with all these components with 7 segments included. Now, I want whichever floats your fancy. Let's go with orange today. But I don't want all these, right? Common anode, common cathode means I have to have the 7 signals going in. I don't want that. I want it in BCD. So all these are all your common. All this no good to me today. So let's go with my BCD 4 input. Click OK. This is what I want. Confirm. And also it's under the indicators family. So under indicators, the hex display, now we know. Click it and done. Okay, so let's close this. I've got all the components I need. Now it's time to wire it up. Okay, so let's wire my 5 volts. I'm going to come here. I'm going to click it so that I can switch it. Directions, click it and join up here. Okay, so this is joined up. Now, I want this fella to also join up here. So let's see whether that will work, right? So I'm going to click my left click, join it. Does it work? Yes, it does. And I want to join this two up. Okay, join this up. Right, and then don't forget I need to go to ground, like so. Like so. Okay, so my logic switches are connected. Now, I want my clear, remember my clear needs to be low, and when I click it, then it goes high to clear. So therefore, I want a pull down logic switch, pull down resistor, logic switch. Okay, so I want it to draw the signal from here to there. Now, what I'm going to do next is I'm going to place a junction. Now, this will ensure that there will be a connection here. So I come here, and boom, there we go, right? And then for my clock signal, it needs to be activated by a falling edge. So what I have here is a pull up resistor. Okay, so it's going to be high until when I click this, it's going to go low. So same thing, I'm going to place my junction over here. My clock comes here, align it, boom, there you go. All right, now this one you have to know, and I had to do a little bit of research which one is my least significant bit and which one is my most significant bit. So it turns out this will correspond to my least significant bit. So I'm going to connect this to my QA over here. This would correspond to QB over here. Now, I realize, now this electrically is still connected, but I don't like it. I made a mistake. So let's get rid of this. I'm going to click it, and we're going to press delete. That's gone. Let's see whether we can make a nice one here. We can. Let's connect up my QC, and lastly, my QD. Now again, I don't like the look of this. I'm going to delete it. Here, and up it goes. All right. Now, don't forget, the clock B has to be shorted to my QA. So I'm going to come here, come here, come here, and short it to my QA. All right. So there we have it. So to simulate this circuit running, I have to press run. Okay, so let's check it out. Let's check it out. So I'm going to tap my key here, click yes. A falling edge gives me a 1. One more time, a falling edge gives me a 2. A falling edge gives me a 3. So suppose I want to clear it. So let's check my clear button. Click it, yes, it clears. All right, so let's see, count, count, count. All right, so we are good. Let's clear it. Now, after watching this, I want to challenge you. I want to give you a challenge. Let's stop this first. Can you create a system add on to this where it counts from 0 to 99? Okay. Now, to help you troubleshoot, we also have all these probes. So if let's say I want to see what the voltage is at any certain point in time, I click this probe. I can come press it over there. Okay, let's run it. So it is a high. You can see that it is a high, and when I close it, it goes to a low. That's why the falling edge creates a trigger. And what I can also do is that to check that this is 0, 0, 0, 1, I come here. Okay, 0. Remember, this is the MSB. 0, 0, and a... Oh, have not clicked it yet. It goes to 1. Oh, wait a minute, hang on. It's because it is always cleared, right? So by now, it should work. Trust me on this. Yes, it goes high because it is 0, 0, 0, 1. Okay? Okay? So let's click it again. Now it should be 0, 0, 1, 0. So let's see. Yes. All right. So let's stop this. Go on. Do the challenge I've set you. Add in another counter. I don't want to tell you too much. See whether you can short a number here to the clock there, and then make another 7-segment display over here. Remember, the tens place is the second counter. And yeah, take a short video, email it to me or send it to me via WhatsApp. Okay, so have fun playing with this, and I hope you learn about using Multisim today.